Well, for this practice, we're going to use our Arduino, our breadboard as usual. We need an external source of power. We're going to use this 9 volts battery. We need also the motor that we're going to control. This is a regular 9 volts motor, but we can use whatever motor that we have or that we want to use. And we need this chip. The chip here is an L293V. You can identify it with the name here on top. We also need some wires to connect. We're going to use these jumpers to make it easier. Okay, to start the connections, I'll begin with the chip. So I'm gonna put it here in the middle of the breadboard. It doesn't really matter where. And I'm going to use only this side of the chip, so I'm going to control only one motor. To begin, I'm going to plug the GND to the negative and the 5 volts to the positive. I'm talking only about the Arduino. I'm going to plug the battery at the end. So now, on the first one, remember the first one is the one that is beside the small hole in the chip. For the first one, I'm going to plug that to the 5 volts of the Arduino. So I'm going to use this red wire and I'm going to plug it here. The second one will go to one of the pins that we set in the program to the Arduino. So that means this is my second one and it will go to the pin number 3. Then the third one will go to one of the leads of the motor. So I'm going to use the green one again to the third pin. There we go. And so I have the first 3. 4 and 5, they go to GND. I'm going to use these 2 white cables and they go 4 and 5. They both go to GND. Then the last 3, I have one that goes to the motor. I will use this yellow one. One that goes to the motor. The other one will go to the other lead of the Arduino. Here it goes to the other pin of the Arduino, which is number 5. And the last one will go with the power source. What does it mean? I have to connect the negative of the battery with the same negative, but the positive will go to the last lead here. And that is the way to connect it. Here for the motors, to the Arduino we're just connecting 2 pins. That means that I have to declare 2 connections. In this case it's 3 and 5. The reason why is because no matter the type of Arduino that you have, pins 3 and 5 are analog. That means that you can send different pulses to create different types of signals. In this case I named them as forward and backward, but you can name them whatever you want. It's just to give me an idea of the direction of the spin of the motor. The motor is an actuator, and since it is controlled by 2 pins, I will say output to both in the pin mode, and I'm just declaring with the name that I gave them. And finally, the actions that will be repeated over and over again. For each action I need 3 lines in this case. The first line will tell an analog write to forward and it will have a 255. If you remember, with analog instructions we have to declare a number between 0 and 255. If I use 255, that means that I'm using the full power, so that means that the motor will go at full speed. But since this is a component that is being controlled by 2 pins, I will always have to declare both pins. And to control the direction, if one of the pins has 255 or has one number between 1 and 255, mandatory, the other one should be 0. Because if I send pulses on both, nothing's gonna happen because it's going to be confused. I can only send the pulse to one of the pins. In this case, I'm sending the pulse to forward with 255, so that means the motor will spin in one direction at full speed because it's 255, and for 3 seconds. Then on the second instruction, which is this one, I'm sending now an analog write, but as you can see, in forward I have a 0, and in the other one I have 125. 125 is kinda like half of the speed, which is what you're going to see on the video where the project is working. So here it will go at full speed in one direction, and then here it will go at half of the speed in the opposite direction. Each motion will stand for 3 seconds. It's delay 3000, and since this is being repeated over and over again because it's in the void loop, it's gonna happen like forever. Okay, and after all those connections, this is how it works. You can identify the speeds because of the sound. So as you can see here, for 3 seconds it goes at full speed in one direction, and then it goes at half of the speed in the other direction. And that's it. That's how you control the motors.